Our short subject today from EducateVirtually.com is multiple regression analysis interpretation. How do we understand which of the input X variables is actually significant and driving our output characteristic Y? Let's take a look at a case study example. In this case study example, we're going to take a look at some sales and marketing information, and we would call this a promotional marketing effectiveness analysis. Our data has been structured for the regression analysis. Our output characteristic, Y, is the unit sold. Our data is tied together by the date. The input characteristics we have, those X variables, detailing, journal advertising, mailings, customer information meetings, the prices of a prescription for 1 month of this particular therapy, promotional items, and sales force spending. These are all activities that are followed by our sales force when they're promoting these pharmaceutical sales. So we want to find out which of these variables has an influence on either driving up the units sold or driving it down or having no influence whatsoever. So when we begin our regression analysis, we start with the initial analysis, and let's take a look at that. So in the initial regression analysis, we start off with, and this is a typical output from a lot of the statistical software packages that are out there, we end up with an equation that says that our units sold is a function of our intercept minus our coefficient times detailing, and then journals, mailings, meetings, prices, promo items, sales force. Everything's included in the model. It says that our R squared value, 95.3%, which means that this equation explains 95.3% of the variation that we see in the units sold. All right, well, how good is that? Well, we look at our analysis of variance, and we see that we have a p-value of 0.000 some number. So that's something much, much, much less than 0.05. And we've always tried to stick with a threshold of a 95% confidence or a p-value of 0.05 or less. But let's peel the onion back a little bit and take a look at the detailed analysis that we have of our variables. Now in this particular case, we're looking at the T statistics. Now the T statistics, if we have a T value with an absolute value that is equal to 1 or less, we know that that is not going to be significant. Let's take a look. Okay, is this T statistic minus 0.07, its absolute value, is that 1 or less? Yes, it is. What's the p-value? 0.945. All right, that's a huge, huge p-value, so we know that that's not a significant factor. So detailing should not be in our model. All right, we can look at journal advertising, mailings, meetings, prices, promotional items, and sales force spending. So what we can do is we can go through on the next iteration of the model. Let's take out some of those big hitters that we know for sure are not significant. They all have T statistics that have a value, absolute value of 1 or less. So that's going to be detailing. All right, that's going to be mailings, and that is also going to include the promotional items. All right, so you can see the p-values are all very, very large, 0.8, 0.95, 0.945. So we're going to remove those from the model and rerun the regression, and let's see what the equation looks like after that. We'll check our p-values of all the contributing variables. We'll look at our R squared again, and we'll look at the analysis of variance and check the p-value. So let's take a look at that analysis after we've removed those factors that we know are not significant from our model. And let's see what happens. All right, well, here is our new regression equation. All right, now this one is a little bit shorter. There's not as many factors in it. If we take a look at our t-statistics, none of the t-statistics are less than or equal to 1. We can look at our p-values and we can see 0.042, 0.01, 0.001, and 0.069. Well, that's right on the edge of 0.05. So we'll probably keep this one in the model and we'll just see if sales force spending makes a difference or not. You see that our R-squared value, 95.3%. So this equation explains 95.3% of all the variability that we saw in the units sold. We look at our analysis of variance and we can see that the overall model is significant. And now that we know that these individual contributors in our model are significant, we can use this equation as a way to predict what might happen to units sold if we vary the input of journals, meetings, prices, and sales force spending. So that's how you begin to interpret a multiple regression analysis when we're trying to understand the significant factors and which ones they are that are going to drive the output characteristic. And that's brought to you today by EducateVirtually.com. Thank you for your attention.